Agricultural University, Ludhiana. Professor Vishwajit Singh Hans has completed the Bachelor of Engineering from Punjab Engineering College, Chandigarh in the year 1991, and then the Master of Engineering from the same institute in the year 1993. He completed the Doctor of Philosophy from Indian Institute of Technology, Roorkee, in the year 2010. Professor Vishwajit Singh Hans has joined the College of Agricultural Engineering and Technology, Punjab Agricultural University, Ludhiana, in 1997 and served in various academic positions for 16 long years. Professor Vishwajit Singh Hans has worked as the director of SESA for 4 years. Currently, he is working as a professor in the Mechanical Engineering Department, College of Agricultural Engineering and Technology, Punjab Agricultural University, Ludhiana, since 2013. Professor Vishwajit Singh Hans has academic experience of 25 years along with a 1-year industrial experience. His area of interest, specialization, and research is the application of solar energy for large capacity drying systems used in agro industries, food processing industries, and agriculture. Professor Hans has published 25 research papers in national as well as international journals and conferences. Professor Hans has guided 2 students of PhD. Professor Hans is involved in various consultancy and research projects and delivered a number of expert lectures. It is an honor and privilege for all of us to have Professor Vishwajit Singh Hans here with us today. Today, he is going to deliver an expert session on solar energy utilization for agricultural applications. His deliberation and expertise on the said topic will surely benefit all the participants. I now invite Professor Vishwajit Singh Hans to deliberate us on this topic.
சாவடிப்போம் டிபிடி வந்து பிரசன்ட் பண்ணானாக்கா எம்எஸ்டி வந்து நாம கண்ட்ரோல் பண்ணலாம்.
Pardon? Hello?
எம்எஸ் நாம டிபிடி ஷேர் பண்றோம். அது வந்து நாம கூட ஷேர் பண்ணலாம் போல. முன்னாடி பண்ணி மாத்துறது.
I think someone has some difficulty.
Can I? Should I start, sir?
Okay, sir. You may start. And if anybody has some difficulty, they can write it in the chat box.
So please allow me to share my screen.
Just one minute. Let me give you the presentation.
Yeah.
Okay, sir. Now you can present.
Okay. I hope my screen is visible to everybody.
Yes,
sir. Yes, sir.
Okay. Thank you very much to the organizers of this Faculty Development Program for inviting me and giving me an opportunity to interact with all the participants, which I believe are from all over. We share topic you please mute your speakers. Thank you.
We have muted all the attendees.
Okay, thank you. So Before I start with my talk of today, I'll briefly tell you the work carried out in PAU. It is relevant to today's talk because in PAU we have got three, Punjab Agriculture University had got uh, three types of jobs for a faculty member. First is teaching, second is research, and third is extension. And the person who is engaged in teaching is supposed to devote 66% of his time to teaching, and rest of 33% is devoted to research and extension activities. Research, similarly, a person involved in research will devote 66% time in research and rest of 33% in teaching and extension. And I hope teaching and research is clear, but I'd like to elaborate briefly about extension. Basically, in the person who is involved in extension, again, 66% time will be devoted to extension activities, rest for teaching and research. Under extension, we interact with the farmers, whatsoever technologies, new varieties of grains, pulses, or any technology developed by PAU is its its knowledge to the farmer is given by organizing various training camps, by organizing farmer melas. We call it Kisan Mela. Every year, two melas are conducted in PAU and its outstation. So we have got around 22 KVKs, Krishi Vigyan Kendras, and research stations, research farms where these melas are conducted. So why I'm telling you all about the reason is in PAU whatsoever research as a faculty member or as a researcher I am doing, it is supposed to have its application in the field, particularly for farmers or agro-based industries. So most of the work which we carry out in the research field that has to be implemented in the agro-based industries or in farmers field. Otherwise, laboratory research out of which we make publication does not carry much weightage. Of course, publications do carry weight, but the technology or the research which we have done, and if its field adoption is there, that carries more weightage. So in PAU, whatsoever work we do, we do it with the aim of taking it to the farmers or to the agro-based industries. So with this background, I will start my talk of today's it's a solar energy utilization for agricultural application. Being a mechanical engineer, so we carry out research in different renewable energy source energy fields like biogas, solar energy, biofuel, etc. But today I'll just confine myself to the solar energy utilization. So there are so solar energy we can utilize in field of agriculture in two ways. First is, as we know, we can utilize solar energy for generating electricity, right? And second is utilizing solar thermal energy in agriculture field. So under the use of solar energy for photovoltaic application is that we can run a solar water pump with the help of photovoltaic panels, and we can use this pump for irrigation purposes. So irrigation could be through flood irrigation, drip irrigation, community water supply, fish farming, poultry farming, or cattle watering. So I will not go into the details of the photovoltaic application of solar energy in agriculture, but I will come to the conversion of solar energy to thermal energy, where heat is generated and that heat is utilized for agricultural applications. So by generating the heat or by converting the solar radiations to thermal energy, we can operate solar crop dryers, solar water heaters, solar air heaters, and greenhouse technology. So my focus today will remain on only solar crop dryers, which have got wide applications in the agriculture. So number of crop dryers have been developed by PAU, and the basic purpose is to carry out the drying of agricultural produce. Apart from that, solar water heaters, we are aware commercially solar water heaters are available. Previously, we were using flat plate solar collectors for heating water, but nowadays evacuated tube collectors are available, and these are also commercially available. PAU has also developed number of solar water heaters of different designs, but all these designs have now become obsolete with the introduction of evacuated tube solar collectors. Then solar air heaters, again, depending upon the type of collector, it could be flat plate collector, it could be concentrating collectors, it could be evacuated tube collectors. So solar air heaters have been developed. Even packed bed solar air heaters have been developed by PAU. But again, with the advent of evacuated tube collectors, all other type of all air heaters using other types of collectors, they are now not used much. Greenhouse technology, again with the help of greenhouse, we can cultivate different agricultural crops, particularly in vegetable field, right? So these are the various applications of solar energy in the agriculture, like solar crop dryer, water heating, solar air heaters, and greenhouse technology. But I will just focus on solar crop dryers. Why solar crop dryers are important? So, as reported by FAO in 2017-18, that total global food grain production is estimated to be 275 million tons. And if you look at the Indian scenario, India is the second large producer of rice, wheat, sugarcane, cotton, and groundnut. As
Sir, the slide is not changing. It's showing the title page only.
oh, sorry,
Yes,
uh,
sir.
okay, only this. Okay, is it visible now?
No, sir.
Excuse me,
Only the
sir, your
title page
slide
is
is not.
displayed.
Okay, just a sec.
Slide is not changing, sir. Only one slide is showing.
Sir, I request you to kindly reshare the presentation screen. Now, kindly put it on slideshow mode.
Sir, only one slide is showing every time.
Is the front one title?
Only the title page is displayed right now.
Ji, sir, ji, sir.
Yes, sir. It is working now.
Okay. 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 As I was discussing, that India is the second largest producer of vegetables, fruits, and it is accounting around 10.9% and 8.6% of world fruit and vegetable production respectively. But out of this, only 2.2% is processed. Rest is sold as it is. So if we do not process our produce, then we cannot store it for a long duration, because because all these fruit and vegetables, they are perishable in nature. So we need to store them, and for storing we need to carry out the post harvest processes. And if you compare it with the other developed countries, particularly USA and China, they are processing USS is processing 65% of its produce, and China is processing 23% of its fruit and vegetable production. And due to these post-harvest processing, wastage is reduced and value is added to the product or the agricultural produce as the shelf life is increased. So Government of India, keeping all these things in mind, they formed a committee for doubling farmers' income. And this committee estimated that Indian farmers incur a loss of rupees 92,651 crore loss due to post-harvest losses. Since we are not doing the post-harvest processing, so the farmers are losing staggering amount of money, which is estimated to be rupees 92,651 crore every year. And to stop these losses, the government has recommended, or the committee has rather recommended, developing infrastructure near the farm in the form of aggregation points such as cooperatives, food processing organizations, where this fresh product is brought for post-harvest processing. And in at these aggregation points, the fundamental and primary post-harvest process is the drying. And drying is the first post-harvest process before further processing is carried out. If the produce is wet, then again its shelf life will be reduced because chances of pest and insect attack increases and losses do occur, and nutritional value of the produce is also lost. And apart from that, because of improper drying of produce, 1 to 5% of total post-harvest losses do occur. So it is very important to carry out the first and primary post-harvest process of drying accurately and according to the nature of the produce. Generally, what is happening nowadays, whenever a farmer or a farm producer organization is carrying out these post-harvest processes, they carry out drying under the open sun. The produce is spread on the kacha or pakka floors and produce is dried under open sun condition. It has got its own disadvantages because of inclement weather. Again, we have to collect it and store it. And once the weather is fine, again you spread it. You have to spend labor on that. Apart from that, it is open to dust because initially produces wet and it will attract more dust, and which will again adversely affect its nutritional value. Again, pest attack also takes place, and most important thing which reduces the quality of produce under open sun drying is discoloration of the product. Most of us have seen that in our houses, generally chili is dried. Chili or any green vegetable, you can say palak or spinach, right? That is dried. When you dry it under open sun condition, you will see that discoloration take place, which reduces its quality as well as its price when it is sold in the commercial market. So to overcome all these disadvantages associated with the open sun drying, solar dryers are most effective and efficient as they remove the moisture from the produce, which not only improve its quality as well as its shelf life. The advantage of using solar dryer, crop dryer is that discoloration does not take place, quality is improved, and time taken to achieve the desired level of moisture in the produce is also less as compared to open sun drying. Now in PAU, number of solar crop dryers have been developed ranging from capacity of 2 to 3 kg up to any capacity greater than 100 kg. So I have divided it into three parts. First is domestic solar dryer, second is multi-product solar dryer, and third is forced circulation solar dryer. And fourth one is a combination of all these that I will explain at the end of my presentation. So these three types of crop dryers have been developed. They are using a different kind of, their application is slightly different, and the technology developed is also different. I will explain it in the coming slides. So first is domestic solar dryer, which is having a loading capacity of 2 to 3 kg capacity. Then if we want to dry a product which is in the range of more than it is more than 20 kgs, then it is multi-product solar dryer. And if we require drying of product which is in the excess of 100 kg, then we use forced circulation solar dryer, right? So in the domestic solar dryer, this is we have got 2-3 designs of domestic solar dryer, but this is the most recent one, advanced domestic solar dryer, for which PAU has been granted patent also. So as you know, the capacity is 2 to 3 kg of fresh produce, and generally the drying time is 2 to 3 days. And for placing this advanced domestic dryer, you need a shadow free space of 80 centimeter into 66 centimeter, and it's having a natural circulation mode. Now we do not have the forced circulation, but only natural circulation. And it can be, when we don't use it, you can place it anywhere. Even wheels have been, this dryer has been mounted on a platform having wheels, so you can easily move this dryer. Whenever it is not in use, you can place it inside your house, but whenever you want to use it, you can move it to the space where you have got sufficient radiation. So I'll just so you can see here, this is the area where radiation are being captured, and from the underside of this portion, air gets into the dryer. As it gets heated up, it moves in the upper direction. So this collector area is connected to this drying chamber. This is the general arrangement. Air enters at the bottom, and here collector is there, and as it gets in contact with the heated surface, black heated surface, as you aware, all of you are aware that black surfaces absorb maximum radiation. So as the air comes in contact with this hot surface, its density decreases and it becomes lighter and moves in upward direction, and it reaches the drying chamber. So I will explain how this drying chamber has been designed. So in the drying chamber, you will load the product or produce which we want to dry, and hot air will carry out the drying. And after carrying out the drying, moisture or the moist air is moves from this part. It is, in fact, it is not visible because it's a two-dimensional photograph. So we have got openings present over here as well as on the other side. Now you can see this is the drying chamber. This is the so in the drying chamber we have got two trays on which the produce is loaded. These trays are made of wire mesh, stainless steel wire mesh, on which the produce is placed. So as the air moves, hot air moves from this side, it moves through the produce which is kept in the trays, and moisture is removed. So the unique feature of this dryer is, if you see all the other domestic solar dryers, you will see a flat surface, black flat surface. But in this dryer, we have placed black metallic rings just to increase the area of dryer or the collector. So these rings are placed in front of that flat surface. So these are blackened to absorb maximum radiation. So heat transfer area has been increased by use of these metallic rings. And drying time as compared to the conventional dryer has been reduced to 40% with the use of these rings. And the cost of this dryer is around 4200 and payback period is around 200 drying days. And since as I have at the start I have told you in PAU more weightage is given to those technologies which are adopted in the field. So apart from the conventional dryers which have been which are in use in the field, I think about more than 1,000 conventional domestic dryers are in use at this time. But now, since we have developed a new advanced domestic solar dryer, more than 150 such dryers have been supplied to individuals in state of Punjab as well as outside. And this dryer is available in the Department of Renewable Energy Engineering PAU as well as our industry partner Vishwakarma Solar Energy Corporation Floor. So I prefer, depending upon whatsoever the participants feel, if you have any question related to this dryer, I can take the questions right now, then we can move to the next technology, or as the organizers desire, we can take the question at the end of the presentation. It is your choice. I'll be happy to go by your choice, please. So if you have any question, please let me know. Otherwise, I'll move to the next one.
Okay, any participants have a query you can raise at this time. Otherwise, we will go ahead for the next presentation. Next one.
Hello, sir.
Yes, please.
Good afternoon, sir. Sir, have you means how you decided that angle of inclination for that solar aerator, sir?
For this crop dryer.
Hello.
Hello.
Ah, sir.
For this domestic crop dryer.
Yeah, this solar aerator, sir, for this.
Okay, crop dryer. So it is the standard procedure depending upon the angle of latitude for for winter and summer application. You can, according to your latitude, you can decide that. Otherwise, for these, which is for winter and summer application, it is 45-degree. And if you can see here, this rod, with the help of this rod, you can change the angle. It has got the slots, and according to the latitude of your place, you can change the angle of inclination. So those provisions have been made.
Okay, and sir, industrial application, there is a standard that 2 meter square is the standard. So how you taken that 80 centimeters by 66?
Two square meter area, if you see 2 square meter area, it is probably for the water heaters, right? Which you are talking, not for the dryers or air heaters. And even if you, again, what is important, what is the length? If you are using 2 meter height or length and 1 meter width, then it will not serve the purpose for air heating. Water heating, it will be. But for air heating, 2 meter length or height will not serve the purpose. The basic reason is that in case of air, the heat carrying capacity is quite less as compared to water. If you make the air move in at a length of 2 meter, and it may achieve maximum temperature at 1 meter or 1.5 meter, depending upon the radiation input. and rest of the length is wastage as compared to water, because a heat carrying capacity of water is 4 times as compared to that of air. So 2 square meter, generally maybe 1 meter height and 2 meter width, that is also acceptable. But again, it depends upon your requirement. How much is the capacity of your system? What kind of temperatures and what kind of flow rates you require? Accordingly, you decide your dimensions. 2 meter height or 2 meter height, in case of water it may work, but in case of air it will not work, that I'm very sure. And in this case, the aperture area which we have chosen, it is depending upon the capacity, because it is only 2 to 3 kg capacity. If we want to have a larger capacity, then we will definitely, if you will be now see in the coming technologies, which I am going to discuss for uh, capacity greater than 20 kg, capacity greater than 100 kg, you will see the aperture area will change, definitely. So the good question which you have
And
asked.
next about sir depth, sir, height.
Pardon?
Height, sir, height. Length and width is okay. Next, what about the height, sir?
See, I'm talking of the height or length. It is 2 meter. In inclined length, you are saying 2 meter. And depth, you are saying it is around um, 30 inches. Sorry, not 30 inches. It is about um, 30 centimeters.
Okay, okay, sir.
So next is the evacuated tube solar dryer, and its loading capacity is between 20 to 30 kg. But again, this loading capacity depends upon the type of produce. If you are using low density produce such as spinach or chili, it could be low. But if you are using high density produce such as turmeric, ginger, loading capacity could be 40 to 45 kg. So here you can see in this crop dryer, we have used evacuated tube collector. Previously, we have developed a flat plate collectors also, right? But with the more efficient evacuated tube collectors, we have replaced flat plate with these efficient evacuated tube collectors. So you can see this is these are the evacuated tube collectors, around 2, 4, 6, 15 evacuated tube collectors have been used to make the solar air heater. So air is heated in these vacuum tube collectors, and again at the top of the collectors you can see there is a drying chamber, and at the top of drying chamber small exhaust fan has been placed, and this exhaust fan is operated with the help of this photovoltaic panel just to draw the moist air out of the drying chamber. Since the produce is more, more moisture will be present, and here we have introduced the circulation of moist air with the help of exhaust pipe, exhaust fan. And this exhaust fan is operated with the help of photovoltaic panel. So air enters these collectors and get heated up, and they move into the drying chamber, where again 3 trays are present in which we are loading the we are loading the fresh produce which is wet or moist, and drying is carried out. And the drying time is 3 to 5 days. Again, for all the technologies, the reduction in drying time as compared to open sun is it is in the range of 40 to 50%. So again, for this kind of evacuated tube solar dryer where capacity is greater than 20 kg up to 50 kg, so drying time has been reduced to about 40 to 50%. Again, it depends on number of factors. Of course, during those drying times, what is the radiation and what kind of produce we are drying. In case of garlic, ginger, turmeric, it takes more time as compared to chili or any leafy vegetable. And only solar energy is required to operate this, and the cost is around 45,000, and the payback period is 300 drying days. So these are the other views of this technology, and you can see this is the view of the drying chamber. So you can see here we have placed 6 trays. Initially we were having 3 trays, one single tray, but we have divided into two. Now we are loading 6 trays. Only instead of 3, we are using 6 trays just for the ease of operation. So it is easy for a single person to handle these 6 trays. Otherwise, if we use 3 trays, the size increases, the capacity almost remains the same, but handling becomes a bit difficult. So you can see this chamber is containing 6 trays, and this is the view of the tray. Again, it is made of stainless steel wire mesh, so that any food product or agricultural product, it does not get contaminated during drying process. And this chamber is insulated from all sides using thermocol, and you can see this is the thermocol which have been used for insulation purposes. And around 13 installation for such kind of dryer has been made by PAU, and these locations are not only in Punjab but across India. So we have installed 2 such crop dryers in Dehradun in a society named Him Uthan Society, which is an enterprise of Tata Trust. So they are using these two multi-product solar dryers for drying the fruit crop of different farmers. And second one is Nature's Urja, which is in Himachal Pradesh, and there's one dryer which has been installed in Punjab in the Moga district, and other location 9 such dryers have been installed. I'm not having the details right now, right? So 13 at 13 locations these dryers have been installed. So any question? Now, as one of the participants have asked about the previous technology, that is domestic crop dryer, about the size. So here the size of the evacuated tube collector, it is 1.8 meter in length, right? And diameter, outer diameter is around I think 51 centimeter, and the inner diameter is 47 centimeters. So during this, air heating takes place. When we initially started working on evacuated tube collectors, we joined these collectors in series, and we carried out the experiment in the month of November, which is pretty cold. In this, the month of November is pretty cold in this part of the country. And when we used 5 tubes, they were connected in series, we were able to get a temperature of 125 degrees centigrade. Initially, when air passed from first collector, its temperature was around 22 degrees centigrade. Then there was an increase of 50 degrees centigrade. Subsequently, in rest of the evacuated tube collectors, temperature rise was there, but the rise was not that much as compared to the first one. First one probably was around 50 degree, then it went to 20 degree, then 10 degree, then 5, 2, 3, like this. But in this collector, we are not using the we are using all these collectors have been connected in parallel, not in series. Okay. Any question, please, if you have?
Mr. Alpesh, you can raise your query.
Pardon?
Yes. How to decide the distance between the each tray in drying chamber?
Or to
How to
loading
decide
capacity.
the distance?
Loading capacity of each tray. Probably this is what you are asking.
Sir, actually, how much amount of gap need to maintain between each tray in a drying chamber? Is it required or not?
It is required because whenever you carry out the drying, I'll just answer in two parts. When you carry out drying, preferably it should be thin layer drying, right? And the depth of this tray is around 4 inches. So we fill this tray up to half of its capacity, right? So when you carry out the thin layer drying, then drying is faster. If you carry out thick layer drying, then sometimes what happens, the lower part or the produce which is present in the lower part of the tray, it comes in contact with the hot and dry air. It gets dried, but as the air moves up, it gains moisture and the upper layer of the produce does not get dried, rather it gets wet. So we have to carry out the thin layer drying and we have to keep almost half of the tray empty.
Hello, sir. How you can control the temperature of this unit?
Temperature can be controlled.
Yes.
Generally, we have not, uh, yes, it can be controlled because for every agricultural produce, the optimum drying temperature is up to 65 degrees centigrade, right? And if the drying temperature exceeds that, then the exhaust fan starts operating. And if the drying temperature is below that, then it will stop working. So you can set that temperature, optimum temperature, depending upon your produce. Like turmeric can be dried up to 65 degrees centigrade without losing its nutritional value. Whereas there are some other crops or such as apricot, and its drying temperature, it should be around 50 degrees centigrade. You can dry apricot up to 60, but some farmers prefer that at low temperature color of the produce as well as the texture of the produce is better. You can control the temperature.
Yes, sir. Thank
Sir,
Yes, please.
what is the value of thickness is considered as thin layer drying, sir?
Then it is basically you cannot if I say 1 centimeter 2 centimeter, again it depends upon the produce and the preference of the user. Sometimes they want faster drying, so they just spread one layer only. So here, as I've told you, the depth is around 4 inches. Half of it has to be left as it is. So up to, again it is depending upon the produce. In case of turmeric, amla, garlic, right, it could be more because it is having more void fraction, but in case of leafy vegetable it has to be lesser because void fraction will be less.
Okay. For leaves, how much it will be, sir?
Pardon?
For leaf vegetable,
For
how
leafy
much it should be?
vegetable, it should be around 1 inches. That's
Oh,
it.
okay, sir. Thank you. Thank you, sir.
So any other question related to this, please?
What about, sir, what about that white portion, sir, in picture?
This one?
Insulation. Huh?
Insulation, yes.
Okay, okay.
Even in some of the cases, we have used puff insulation also, but it is a bit costly, and since this product has to be used by mostly FPUs and farmers, so the cost is also has to be kept a bit low. We have approached Punjab Energy Development Agency, which is a nodal agency for renewable energy technologies. They have also funded around 9 of such dryers, which are installed at food process organizations, small cooperative societies. They are uh, processing uh, fruits and vegetables. They are also into pickle making also. So they are funded the entire cost for such organizations. So again, our industry partner is Vishwakarma Solar Energy Corporation. It is situated in a town of Philor, which is near Ludhiana. Now next comes the forced circulation solar dryer. This is the dryer which has been adopted in maximum number, not only in Punjab but at the national level also. We started working on this dryer in the year of 2010. We came across a number of agro-based industries which wanted to have large capacity dryers, which they can use commercially also. Otherwise, till then we were having these small capacity dryers which were to be installed at in a uh, in a house or at the domestic level, or small agro-based industries which were having a capacity of 40 to 50 kg. We realized that if we want to use solar energy for drying of crops, then we need to have large capacity systems. So we visited a food processing organization which is called FEPRO. And in this society, there are 300 farmers which are into the cultivation of turmeric only. They are not into the cultivation of wheat and paddy. As you are aware, probably in Punjab, a lot of emphasis is now going on that paddy and wheat because of depleting water table. We are using excessively groundwater for cultivation of paddy. Right? And due to that, water level is going down, and turmeric is seen one of the alternative crops. So we thought to focus on this so that we can help the farmers in carrying out the post-harvest processing. So whenever you cultivate turmeric and you carry out post-harvest processes to sell this turmeric powder, it has to undergo 4 processes. First is washing of the turmeric, or you can say in washing, we we don't wash it. Basically, it has to pass through steam, right? Turmeric is kept in the in a sort of boilers where they are steamed for 10 minutes. By steaming, the quality of turmeric improves because quality of turmeric is determined by 2 aspects. One is curcumin content and second is oil content. So if you do the steam treatment of turmeric, these parameters improve. So but when the turmeric, freshly cultivated turmeric comes after washing, it is steamed, then it is wet. So you have to dry it. Initially, farmers were spreading, and that society was uh, spreading the turmeric on a pakka floor and used to dry it. So you can well imagine that 300 farmers, they were into turmeric cultivation. If you assume only that each farmer is having 1 acre of land, right? So 300 acres of turmeric is available, and from each acre approximately 100 quintals of turmeric is harvested. So 300 into 100, right? Of course, those farmers are having more land with them. Just to give you an idea how much open space and pakka space is required to dry the turmeric under open sun conditions. And in Punjab, turmeric is harvested in the month of January to February, at the end of January or at the start of February. And such large quantity of turmeric has to be processed before the onset of monsoon, which is end of June, right? So I was telling you, after drying, it has to be polished. Polish does not mean you have to apply something, but polishing means that you have to remove the outer skin of the turmeric. After polishing or removal of the outer skin of the turmeric, then it is converted into powder form by using grinders. Then it can be stored and marketed, right? So there are 4 processes for turmeric to be sold in the market, or before it is, you can say, marketed in the form of powder. First is harvesting, then washing and steaming, then drying, then polishing. Again, I'm saying polishing means removal of the outer skin. And fourth one is the grinding of the solid turmeric. So we've decided to focus on the drying part. So we visited that society, and after 2-3 years we came up with a design which was able to meet the requirements. So I'll just show you the uh, schematic of forced circulation solar dryer. So at the onset, I'll tell you it is a forced circulation dryer, means air is forced over the agricultural produce which we want to dry. So this dryer, forced circulation dryer, has 3 major components. First is the solar air heaters. Second is a greenhouse in which produce is placed on these vertical trays having gap in between, and on these trays are made of angle iron, and trays are placed over these structures, and trays, in these trays we have used stainless steel wire mesh so that air can pass through this wire mesh and dry the produce. And third component is the drying chamber, right? So as it is clear, these solar air heater, greenhouse with these trays, and the drying chamber. These are the 3 main components. So you can easily make out air heaters. Again, evacuated tube collectors are used in these air heaters, and these collectors are connected in series, and air is heated. So this hot air is fed to this drying chamber with the help of a blower, and in this blower is operated by electricity, right? And generally it is of 1 kilowatt capacity, right? So this dryer which we have designed for turmeric drying for that society, it is having a capacity of around 700 kg. So 1 kilowatt capacity dryer blower is required to push the air into this drying chamber, and this blower and air heaters, they operate in a closed circuit, right? And air is not only heated with the help of these air heaters, but this greenhouse also helps in increasing the temperature of the air which is present over here because of the greenhouse effect, you can say. Generally, a greenhouse, in a greenhouse, temperature of air is higher than the atmospheric uh, temperature of air, in the range of 3 to 8 degrees centigrades during the daytime. At night, it is higher, but only by about 1 to 2 degrees centigrade. Okay? So air is heated in the air heaters as well as in this greenhouse. Of course, the final heating is taking place in these air heaters, where temperature at the outlet is in the range of 50 to 60 degrees centigrade depending upon the radiation. So The hot air moves to drying chamber. In this drying chamber, again, trays are present where product is loaded, right? I'm just explaining the working right now, how and when the product is moved to the drying chamber, that I will explain later on. If I start right now, it will complicate the thing. So initially hot air, which is sucked from the inside the greenhouse, is coming to these collectors. So collectors where air is heated, and with the help of this blower it is fed to the drying chamber. Then produce is present over here, drying takes place, still air is having its heat capacity and it is air is still hot. That hot air moves from the drying chamber into this greenhouse, and in this greenhouse air fans are installed to circulate the air through these trays, right? And to control the humidity in this greenhouse, a exhaust fan has been attached, and a temperature controller has also been attached to maintain the required level of temperature as well as humidity. So this exhaust fan is controlled by a humidity controller. If we set, generally we set that the humidity level should not increase 70% in this greenhouse. If the humidity level increases beyond 70%, then this exhaust fan starts automatically and it will help in expelling the moist air. Then fresh air is again sucked by this air heater, heated, moves to the drying chamber. From the drying chamber, it carries out some final drying is carried out in the drying chamber. Initial drying is carried out in these trays. So I will explain what is the meaning of final and initial drying. And if the humidity is more than required, then exhaust fan will start automatically. And similarly, if the temperature exceeds 60 degree or as set by the operator 60 degree, 50 degree, 45 degree, then again exhaust fan will start, it will expel the hot air to the atmosphere, and this exhaust fan you are aware that it will continue to operate till the temperature is below 45 degrees centigrade or the set limit, right? I hope in general the working of this forced circulation solar dryer is clear. I repeat, hot air is generated in the greenhouse also, and then final heating of air takes place in this evacuated tube solar air heater. Blower helps in moving the hot air to the drying chamber where final drying takes place, and the air which is carrying out the final drying still has got, it is hot, then that air is moved to the these this greenhouse where these fans help in circulation, in circulating the hot air over these, over the trays placed in these structures. To control the humidity and temperature, the exhaust fan is there, which is controlled by a humidity controller and temperature control. Okay, any question about the working which I have told you till now? Okay, I move ahead. I will take the questions later on if any. Now you can see this north wall of this greenhouse has been insulated because this side as well as this side will receive radiation, but north wall will not receive radiation. This greenhouse is facing south. So from this wall, north wall, only heat will be lost. So we have insulated this north wall so that the temperature remains within the required limits. So, and now this is a door which is of course will remain shut and it is also insulated. Through this door, produce will be loaded on these trays. Each structure is having around 6 to 10 trays depending upon the capacity of the dryer. When I will say capacity, it is the loading capacity per day. If I say 300 kg, it means 300 kg of produce will be loaded every day. Then if it is 700, it means the loading capacity, not the drying capacity. Right? So what happens when we have to carry out the drying of turmeric? The wet turmeric is loaded in these trays, right? In these trays, and this drying chamber is kept empty. In this also we have got 5 to 6 trays. So initially what happens when we load the wet turmeric in these trays and this dryer starts working, since the turmeric is wet, it has got more moisture on its surface. So as the surface moisture is removed, most of the time for the first 1 or 2 days, this humidity in this greenhouse is at a higher level, more than 70%. So this exhaust fan is almost, it remains working. After the first 2 days, then the surface moisture has been removed and product is dried, and the volume also shrinks to certain extent, right? After 7 days, after 5 to 6 days of drying, then every day 300 kg of produce is loaded, and after 5 to 6 days, every day we can load 300 to 200 to 300 of produce in this dryer. After 10 days, what happens? After 7 to 8 days, what happens? The produce or turmeric which we have loaded on the first day, its size has reduced, it has shrunk because it has lost moisture. It is moved to this drying chamber corresponding to 300 kg of turmeric. Since the moisture has been removed, that turmeric comes into this drying chamber. So within a 1 day, the final drying temperature or final moisture content is achieved in this chamber. Then after 10 days, turmeric is removed from this drying chamber. Then next load of the turmeric is loaded into this final drying chamber, and fresh turmeric is loaded in these trays. So like this, after 10 or 11 days, again depending upon the radiation at that time, we can take out dried turmeric corresponding to 300 kg of fresh turmeric from this drying chamber. So final drying is taking place in this drying chamber, and in this drying chamber moisture removed is quite less. That is why air is still hot and dry, and at the outlet has been provided, and so that air can be used to remove the moisture from the turmeric which is loaded over here. I hope it is clear. If there is any doubt about the loading and unloading of the turmeric or the produce, you can ask me, please. Any questions,
Hello?
please? Yes, please.
So what is the effect of ambient air humidity on drying rate?
It has a very profound effect. If the air is dry, then the drying rate is very fast. I'm happy that you have asked this question because we have uh, installed these dryers in the different regions of the country, starting from northeast to the Leh Ladakh. In Manipur, we have installed the dryer, and in Leh Ladakh, we have installed the dryer, and in Punjab, of course, in the northern states also. So if you carry out the drying in these different regions, you will see in Leh Ladakh the drying time is reduced because the ambient air is quite dry as compared to Punjab, because nowadays in December, January, humidity of air is very high right now, whereas in Leh Ladakh, even during winters, the humidity is very less. And in southern states of the country, they don't use these dryers. They only use this greenhouse without these evacuative dryers, because humidity is quite less in those states and drying is faster. They can achieve the drying by using only the greenhouse. So depending upon the location, since we have designed it for Punjab and where humidity is quite high as compared to other states, we have to do the heating over here. And the you can ask me, then in states where humidity, like in Leh and Ladakh, where humidity is less, in that case we need not these dryers, but we can increase the loading capacity of the dryer. Instead of 300 kg, we can load 400 kg, because moisture removal rate is quite high. I hope it is clear.
Yes, sir.
Okay, any question? Okay, now coming to these are the some installation, as I've told you about the society of 300 farmers which are into turmeric cultivation. So this dryer has been installed in the premises of that society. You can see this is a pakka floor, right? And this floor was used to dry turmeric under open sun conditions. So when we installed this dryer over there, the drying time reduced to 55%, and quality of the product was better in terms of not only color but also their uh, other quality parameters which I have mentioned, uh, curcumin content as well as the oil content. And apart from why this and apart from that, polishing loss was also less. Polishing means that removal of the outer skin, it was also less. The reason is, when they were drying the turmeric under open sun condition, as I mentioned earlier also, that when produce is wet, it will attract more dust. So to remove that dust, more skin has to be removed. But in the under the forced circulation solar dryer, the product is not exposed to the atmospheric dust. So polishing loss is also less. And color is also better, quite better as compared to open sun drying. So you can see these are the photographs of the inside of the greenhouse. So you can see these are the structures on which racks on which these trays have been placed and turmeric is placed. Right, this is the front rack. This is the uh, uh, racks placed near the north wall. You can see these are the front racks. These are the racks which are placed near the north wall. Okay. So these are the trays which have been placed in the drying chamber, where final drying was carried out. So as I've explained over here, drying is done in two stages: initial and final drying. Right. So we have placed the blower inside the greenhouse, just to thinking that some heat will be generated in the blower also, that we can utilize over here. So this is the inside view of the um, empty greenhouse. This is the exhaust fan, which I have told you, which is operated or controlled by humidity controller and temperature controller. So these are the sum of the, this is the summary of the turmeric dryer. In the, we have carried out a comparison in terms of drying days, polishing loss, curcumin content, volatile oil content, and color. So in solar dryer, it took 10 days, whereas in under open sun drying, it took 18 days. And polishing loss in case of turmeric dried in solar dryer, it was 2.8%, and in open sun drying, it was 3.8%. Curcumin content is 3.1%. Under open sun drying, it is 2.9%. Volatile oil content 6.1%, and under open sun drying 5.8%. No doubt it is marginally better, but it is better. And color, of course, these are the L and A, B values, which are determined with the help of an instrument. So these they have got different significance. So I will not go into the details of food processing, but they are better. This is as I have given the name of that society. This is Farm Produce Promotion Society called FEPRO. It is situated in district Hoshiarpur of Punjab. I'll just show you a video. Yes. So this was just a, video of installation at that society. Now next one of next installation is at the field of a farmer. In fact, the person is not, you can say a farmer, he is a technocrat. He retired from the Hindustan Motors HMT Pinjore near Chandigarh as a general manager, but he got interested into farming as he wanted to go for the cultivation of crops other than wheat and rice. So he went for the cultivation of turmeric initially, and then he started. His was a very is a very unique example. So he is living near Chandigarh. There's a town called Mohali. So he is living there, but he is managing his farm near Jalandhar, that is village Kankor. Why his example is unique? He not only produced turmeric or other crops, he marketed these crops in a unique way. So as I have shown you the installation over there, he is not drying turmeric, chili, ginger, garlic, and bitter gourd or karela, which you call, right? So why he went like initially, as I've told you, turmeric is cultivated at the end of January or at the start of February. Then before the onset of monsoon in Punjab, that is at the end of June, turmeric has to be processed. It has to be grinded and ready to be marketed. So for the rest of the season, he thought that the dryer is idle. I should utilize this. So he bought chili, ginger, and garlic as well as bitter gourd from market, dried them, and He ground these and made powder of all these produces: turmeric, chili, ginger, garlic, and bittergourd. So he made powder of all these agricultural products. So what he did, he obtained certification from FSI also, and he created a packet of all these products which are in the powder form. So he packed turmeric, chili, ginger, and garlic. Bitter gourd he introduced later on. Initially, he started with packing turmeric, chili, ginger, and garlic in 4 small bottles, and cost of each bottle was 50 rupees. So these 4 bottles, they were packed in a packet, and he sold these packets in the Sabji Mandi of Mohali. In Punjab, there is a system of Apni Sabji Mandi where farmers produce their produce and customers directly buy from these farmers. So initially he started with around 50-60 packets per month in that mandi. So every month this mandi happens 4 times. So he was able to sell 50-60 packets, and later on he graduated it to 600 to 700 pre-COVID period. Okay. So he was selling 600 to 700 packets. Each packet was worth 200 rupees, and it was again he was not into earning of profit for himself. So what he did, there are women entrepreneurs, or you can say women sellers. They were having their self-help groups. So he used to give this packet of worth which was worth 200 kg on a discount of 10%. So these women would get these packets for 180 rupees and sell it for 200 kg. So he developed such kind of linkages. Also, just to show others the way that you can go for cultivation of other crops instead of wheat and water guzzling rice or paddy. So here this is another important aspect which I want to show. This is a green net which has been placed inside the greenhouse. You can see this is the front rack, and green net is covering it, as well as this upper green net is also covering this rack. The reason is we want to avoid exposure of the produce to the radiation, direct radiation, because even inside this greenhouse discoloration takes place. So this here, as you are aware, the drying is carried out by the hot air, not by the radiation. So radiation have been radiation shield have been provided over this rack so that the produce is not exposed to the radiation. And this is a fan, which a number of fans are installed inside the greenhouse to enhance the circulation. Right? Similarly, the back row has also been provided with this radiation shields or green nets. So and again, what happened when we went for installation, you can see these solar panels over there. As I've told you, uh, fans are there inside the greenhouse, and a blower is there which require electricity. So in the village, he was not getting regular supply of electricity, but he was having a 2 kilowatt of solar water pump, which uh, which was not operational because the depth of water has gone down. So these PV panels were lying idle. So instead of using AC blower, we used DC blower as well as DC exhaust fan and circulating fans, and connected these DC blower, fans and exhaust fan with the photovoltaic panel. So this solar dryer is completely operated by solar energy. No grid connected energy is used over here. So this is the unique feature of this crop dryer which we have installed in district Jalandhar. So I'll just show you a video of this installation. You can see I've just paused the video. These are the small packets containing turmeric, ginger in the powder form. So this is his brand HRJ. So ginger, chili, garlic, and turmeric in powder form is packed in these 4 containers, and then these 4 containers are packed in the packet which is sold to the customers. Okay, somebody was asking question, please. Yes.
Sir, video is not visible.
Not visible?
Yes, sir. Video is not visible to us.
Okay, let me see what can I do with this. Okay. This slide is visible?
No, sir.
Slide is not visible.
Earlier video was also not visible, sir.
Oh, that's bad. Let me see. This slide is visible. Solar dryer installation at small food processor.
No, sir.
Slide is not visible, sir.
No, not visible, sir.
Sir, in MS Team, at the top right corner, there is a leave option. Then in the behind up arrow key, if you click on up arrow key, you will find the screen sharing option.
Can you repeat it, please? Where?
Sir, in a top right corner,
Okay.
there is a up arrow key. In MS Team.
Adjacent to leave.
Adjacent to leave.
Adjacent to?
Adjacent to leave tab. Top right corner.
Sorry, I'm unable to.
There is a tab, sir, which is having up arrow key notation at the top right corner.
Top right.
There is a tab which is having up arrow key notation.
Sorry, I'm unable to view it. because I have got two windows opening. Sharing. Okay, just a sec. Let me try. Now this slide is visible fully
Yes,
solar
sir.
power.
Yes, sir. Your slide is visible.
Okay, this is also visible.
Yeah, sir.
Click here to view video.
The slides are not moving, sir.
Was it visible or not?
Sir, your screen
No,
is visible.
sir.
Screen is visible, not the video.
Video is not visible. Yes, sir.
Now it is visible.
Okay, 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 okay. Now I'll go back to that. Now I think it should be visible.
Yes, sir.
Yes, sir.
Now you can see these are the containers in which different agriculture produce in powder form has been placed, has been uh, packed. So the HRJ is the brand name of the farmer. So it is having dry Karela, you can say bitter gourd. This is chili powder, then garlic, turmeric. So these four containers are packed into a packet and sold to the customers at the rate of 200 rupees. So 180 to the women who working in self-help groups. Then these women sell this packet at the rate of 200 rupees, earning a profit of 20 rupees per packet. And every month he was selling around 6 to 700 such packets in Mohali. So that was the unique aspect of this. And apart from that, we have also installed this dryer in Ludhiana city itself. We have, if somebody has happened to in Ludhiana, there is a old city, and in that old city we have got a market which is called Choda Bazaar. So in that bazaar we have got a small food processing unit which is making vadiya. Vadiya is actually uh, pulse is ground, then oil is added, and different masalas and they are added, and then they are dried. It is called vadiya in Punjabi. Vadiya. You may call something else at your place. Most of you must have seen it and used it, but once you see it, you may realize what it is. So in that processing unit, what they used to do, those wet bodies, they were dried in two phases. First phase was drying in under open sun condition. Since this body was wet and containing oil, it used to attract a lot of dust. Then after the initial drying for a day, this product was loaded into electric dryers, and the consumption of electricity in this dryer was around 11 kilowatt hour. Right? So we installed the dryer over there. So the initial drying, which was carried out under open sun condition, it was carried out in these forced circulation solar dryer. Then after the initial drying, again it was loaded to the electric dryers and produce was being dried. But with the intervention of forced solar circulation dryer, the monthly reduction of 20,000 rupees was achieved in the electricity bills. And the industrialist has invested 90,000 rupees, 90,000 rupees in installing this dryer, and he was able to cover his cost within a year. I can safely say that within a year he was able to recover his cost. So I'll just show the that video also. Now this you can see this market is very busy, very busy. It was very challenging to install the dryer over there because we have installed at the top of the third floor. And before this is the place Amritsariyan di Hatti, right? So you can see here a lot of electricity wires. It was a big challenge to to shift the dryer from this level to the top of the third floor. So these are the few videos of installation with at the field level. So these are photographic views. Initially, they used to dry these verdias under open sun condition in these trays, and this is the electric dryer. The trays were there, and capacity of each tray was around 24 kg. And in this electric dryer, electric fans were installed and heaters were installed. So the total consumption was around 11 kilowatt hour. So, so this is the another picture of the dryer which have been installed in the agro processing unit. So this is the inside view. And apart from that, this is another cooperative society which is doing lot of work for the farmers of Kandi area of Punjab. Kandi area, just for your information, I want to show you that it is a semi-hilly area where lot of produce is available in the forest. Farmers collect that uh, produce from the forest and bring to this society for processing. So the major produce is amla. They are into processing of amla. They make amla candy, amla barfi. Apart from that, jamun, bitter gourd, lot of things they are doing. And the capacity is 700 kg. I think around 100 to 150 workers are working over there in this unit. And this is the inside view, and they are doing it very scientifically. The person who is office bearer of this society is a microbiologist, so he is very keen about the hygiene and other aspects of this processing. So this is also another unit. This is a video which I don't think, if you are interested, I can show you. Otherwise, I will move to the next technology. Right? Similarly, this is, if you want, I can uh, run this video for a minute. It is up to you, right? But preferably, if you can see it in the next one, that will be more better. This installation has been done in a village Dharampur, again near Talwada, is again a Kandi area. This installation has been carried out on a hilltop. The farmer's house is situated at the hilltop, and we have installed this dryer over here. These are the solar air heaters, and this is the greenhouse in which produce is stored. Right? So this is the
Sir, I want to ask one question.
please.
Sir, what is the most popular use of solar dryer?
You're asked. You're asked. I don't know how to answer this question. Solar dryer, like depending upon your requirement, whichever
Okay.
produce. Okay, I'll answer it in a different way. Whichever produce needs to be dried can be dried in this solar dryer. Like in Leh and Ladakh, farmers are facing challenge in drying apricot. Right? What is happening over there, because of certain regulations, there is some insect or some pest in that apricot of Leh, which uh, which which makes its marketing difficult in other parts of the country if they market the fresh apricot, right? J&K people say, even J&K Himachal say, if the fresh apricot is marketed, fresh apricot from Leh is marketed in Himachal Pradesh and J&K, it will affect their apple crop very adversely. So farmers need to try that. And in Punjab, turmeric is another crop which needs to be dried. Apart from that, in Kandi area, it is the amla which needs to be dried before its candy is made or barfi is made. In northeast, again, turmeric is there which needs to be dried. And in Bihar, again, Bihar as well as in Madhya Pradesh, they are interested in drying the medicinal plants. So generally, if I looking at our experience, of these field installation, generally these dryers are installed for turmeric drying, amla drying, and drying of medicinal plants. These are the further applications.
Okay, sir. Thank you, sir. Thank you so much.
Sir, video not visible.
Now is it visible now?
It's visible now.
Yes, sir.
Why I am keen to show this installation is because it, as I've told you, it has been installed at the rooftop, and the last part of the journey to the hilltop is very difficult. It is a steep ascent. This is so these are the few videos of the installation. So I have divided the installation in two categories, outside Punjab and inside Punjab. So these are the installations of this forced circulation solar dryer, which is having capacity more than 100 kg in different states of Punjab. So this is Himothan Society Dehradun, which is a enterprise of Tata Trust. So one dryer has been installed in Dehradun. Second one again at Himothan Society. It is Daguda in near Nainital, and there is another village near Nainital, Kotabag, where and the installation and the capacity of both these installation is 135 kg. Then, as I mentioned you, for drying of apricot,
Excuse me, sir.
again with the Himothan Society has installed.
Hello, sir.
Yes,
Slide is not moving, sir.
not visible.
Slide is not moving, sir.
क्या अमित नहीं है? अमित?
Is it moving now?
Yes, sir.
So these are the 10 installation
Sir,
outside.
one question is there.
Right, please.
विवेक से फोन क्यों नहीं उठा रहे विवेक का?
The installation and erection is quite
बात करो ना,
fantastic,
लगाओ।
but how about the maintenance and
अरे लगा लो, बहुत
maintenance
परेशान है।
cost?
कल से तुमको ज्वाइन करना है कि नहीं करना है? नहीं ज्वाइन करना?
Mic is on.
Sorry.
तो मतलब ज्वाइन नहीं कर रहे हो कल? तो उनको
Is
यही
my
बता दो
question
ना।
audible to you, sir?
Yes.
लो उससे बात ही कर लो लगे। हाँ
Please mute your speakers, please. Okay, your question is how installation is done and what about the maintenance issue, right?
Maintenance.
Okay. For installation part, of course, an educational institution or research institution cannot undertake installation at its own. So we have transferred the commercial rights to an industrial partner. So that industrial partner takes care of the installation as well as the maintenance part if required. The major maintenance requirement is that cleaning of the evacuated tube collectors. So the end user is told about that he has to do the cleaning so that there is no dust deposition. Even after every 15 days, if there is a dust deposition on the greenhouse, that needs to be washed. This because all the other things are very simple. We can easily maintain that. If there is any fault in the electrical connections regarding the running of the blower or exhaust fan, a local electrician can do that. Yes, of course, if there is a breakage of the tubes, even then when we install, we keep at least 2-3 evacuated tube collectors spare at that installation. Then the person of the industry partner goes and changes that. So that has been taken care of at in the initial cost itself. Apart from that, if there is a major damage, sometimes what happens in the forest area, monkeys are there. If they damage the greenhouse, then greenhouse like they tear the LPD sheet. That has to be replaced again. That our industry partner undertakes such kind of repair work. As I've showed you in the installation where the person is packing all these produce in 4 different containers, in that part of the Punjab, due to flooding, entire at least there were 3-4 feet of water at that installation site. Then we sent our own institute mechanics to carry out the cleaning, and we do support the farmers in that. If something has to be replaced, then our industrial partner comes into the picture. Minor repair, he does it without charging anything because farmers need to be supported. I hope it is clear.
Yes, sir.
So recently, apart from Himothan Society, this in Leh also we have installed Gurgaon, Manipur in Northeast, Bihar, ICC Foundation have funded the installation of 1000 kg capacity dryer. Then recently in Madhya Pradesh, 3 dryers of 100 kg, 1000 kg capacity each are being installed. Right? Then in Himachal, there's one Colonel P.C. Rana who is called Turmeric Man of Himachal Pradesh because he is into turmeric cultivation. We have installed 100 kg capacity dryer over there. So 10 installation outside Punjab and 13 installation of different capacity in Punjab. So 700, 700, 700, 200, 100 kg. So more installation are more and more queries are coming, and we are getting a lot of queries from Gujarat also, and Gujarat, Maharashtra also, and in due course of time we will be, God willing, we will doing the installation. And apart from that, from international level also we are getting queries, but we are unable to right now find a way how to go about those installation. Indonesia, particularly Africa, we are getting queries for this trial. Okay, again, industry partner is same, Vishwakarma Solar Energy Corporation. And now lastly, briefly, I will explain another solar system which has been used to add value to the farmer produce. In Punjab, there is a crop of onion in Kharif season. Kharif season is in winters, January, February. But this crop of onion is not getting good price for farmers because they have to sell it in a green onion after harvesting. Because if they keep this onion for some days, then rotting and sprouting takes place. I'll just show you what is sprouting. This you can see this green part coming out. This is sprouting. When this sprouting takes place, yes, is there any question?
Sir, slide is not moving, sir. Sorry to say.
What is happening? Sorry.
Ah, yes, sir. Yes, sir.
It is visible?
Ah, yes, sir.
Okay. This green part is sprouting. So when sprouting takes place, then nobody, because sprouting means the quality is poor. Apart from that, sprouting, what happens? Rotting also takes place. So प्याज गल जाता है. So if you try to keep it, so we farmer need farmer
सबमिट कर दिया वाला डॉक्यूमेंट चलो ठीक
sell the onion after
इसको सबमिट
harvest.
करके आए
That time he will get around 10 rupees per kg. But if he is able to store it for some duration, so say 1 month, 2 month, then he will get around 40 to 50 rupees per kg. So for adding or enhancing the shelf life of Kharif onion, there are two methods. You need to cure it. Curing has two methods. One is you have to treat it or you have to store it in the under the refrigerated conditions. You have to carry out the drying in the refrigerator because humidity is less, so drying takes place. Once drying takes place, then microbial activity stops and rotting and sprouting will stop. But as you know, maintaining the refrigeration temperature it is around 2 degrees centigrade, it's energy intensive. And another option is that you heat the green onion up to 30 degree centigrade and then curing takes place. And again, it also stops the microbial activity. So we designed the heating system. So what we did was that we designed a curing system in which temperature of the room in which onion was stored was maintained at 30 degrees centigrade throughout the storage period. So we carried out, so again we were having an insulated room in which tray racks were placed and hot air was supplied and temperature was maintained 30 degrees centigrade 24 hours a day. During daytime, hot air was supplied with the help of evacuative solar collectors, and during night time when went down, temperature went down, we use electric heaters. Right? So temperature was maintained at 30 degree centigrade, and you can see the storage of onion during the curing period in this rack and tray system. So this was the electrical part where heater was also there, exhaust fan is there. If temperature increases beyond 30 degree, it used to get operated, right? And with, and onion was cured for, we performed experiment. It was cured for from 3 days to 21 days. And then after curing the onion for under these three different days, it was stored for 90 days under room conditions. So what we found that after 9 days of curing, we got the optimum mix, that only 5.9% onion Pardon? Slide is moving or not?
So no, sir.
I don't know what is happening. Now is it visible? Result part is visible?
Yes, sir.
Yes, sir.
Yes, sir.
Next slide has come up or not?
Yes, sir.
Okay. After 9 days of curing at 30 degrees centigrade, we were able to achieve the optimum mix, right? And the average weight loss during curing was 15%. After 90 days of storage of this cured onion, only loss of 9.4% was observed. And the farm we brought the onion from a farmer, and he was able to sell it after 90 days or after curing of onion at a rate of 45 rupees per kg. Initially, in the previous case, he was selling the green onion without curing at a rate of 10 rupees per kg. So this market value changes with season to season also. But for that particular farmer, there was an increase of 30 to 35 rupees per kg, right? And he could store his onion for 3 months. So this is the photograph of onions which were cured for 90 days, 9 days, and after storing for 90 days, only few very small percentage got sprouts. And this is the photograph of onion which were uh, which were not cured, and after 30 days 41% onion got damaged due to sprouting, and after 45 days of storage they were completely rotted. So after curing, if you compare, after curing, 90 days of storage was achieved and only 9% of onion was damaged due to sprouting, no rotting. But without curing, onion 41% of onion got damaged after 30 days due to sprouting, and after 45 days of storage it got completely rotted. So approximately cost of this system is 90,000 and payback period is around 3 years, depend if we have assumed that this system is used 6 times in a year. So this is all about from my side. Uh, if there is any question, sorry I have gone beyond the time limit because of my apologies for that. And if you have any question, please, I will be happy to answer those.
Hello, sir.
Yes, sir, please.
Sir, which material you prefer for a major component, sir? Like absorber plate, greenhouse cover, uh, that glazing material, insulation material, all that.
Murli, I don't do. दो कर दें डॉक्टर धर्मेंद्र जी. Actually, glazing material and absorber plate material, all these components we need to select in case of flat plate collectors or concentrating collectors. But here now we are using evacuated tube collectors which are commercially available. So we are not select whatsoever material is being used for production of commercial evacuated tube collectors, we are using that.
And that's a POA patent you use, means show now.
That is for domestic solar dryer, right? In that domestic solar dryer, of course, okay, I'll go back to that. There we have used all the material which is normally available, right? Glazing, it is a GI sheet of 16 gauge GI sheet, and which is painted with a black wood paint. And these rings, if you are visible to you, these domestic solar dryer is visible now to you, that slide? Yes or no?
No, no, sir. Ah, yes, sir, visible.
Now the back plate is made of GI sheet, which is having probably 16 gauge GI sheet, and it has been painted with a blackwood paint, which is normally available. And these rings, they are made from GI sheet, and again they are painted with a blackwood cover. And normal window pane is used as a glazing, and thermocol is generally used as insulating material. And this box is made of GI sheet. Drying chamber is made of GI sheet, and these trays are made of stainless steel mesh supported by these stainless steel strips.
And what about greenhouse glazing cover, sir?
It is only uh, low density polyethylene sheet.
LPT sheet. Okay.
Yes. And I just caution one thing, this sheet needs to be replaced. We recommend that it should be replaced after 3 years of use.
Okay, sir. Okay.
Any other question?
Sir, what is the
Yes,
yes,
please.
sir? For indirect solar dryer, what is the ideal mass flow rate of air?
In which one?
Indirect mixed mode solar dryer.
You're talking about multi products for solar dryer of 20-30 kg, or
Not for single product, sir.
single product. Okay, generally using flat plate collectors, if I remember correctly, it is 0.65 kg per second mass flow rate, if I remember it correctly. Right? Otherwise, in terms of Reynolds number, when we are saying forced circulation dryer, the Reynolds number for optimum operation of collector is it lies between 12,000 to 14,000 Reynolds number. Corresponding to that, it is I think 0.65 kg per second.
Okay.
If I remember.
Okay. Thank you, sir.
Okay.
Okay.
If any participant have questions. Okay. So, on behalf of the GEC Bhuj, uh, my voice is audible.
Uh,
So,
yes, it
on
is.
behalf of GEC Bhuj, I give thanks to the Professor Hans for delivering such an informative and a nice expert session. So, I again thank Professor Hans for sharing the valuable time. Thank you, sir.
Thank you.